For our graph classification problem, we'll split the graphs in our data set into training data, validation data, and test data. I set a random seed torch, manual seed to 1, 2, 4, 5 so that the results are reproducible for you. On line 3, I called shuffle on the protein dataset, and I select the first 700 graphs to be part of the training data. 200 graphs from 700 through 900 to be part of the validation dataset, and the remaining graphs to be part of the test dataset. And then I print out the lens of each of these datasets to screen, so 700 training samples, 200 validation samples, and 213 test samples. Usually, when you perform graph classification, the graphs in your dataset tend to be fairly small. A good idea in this case is to batch the graphs before inputting them into a graph neural network to ensure that you're maximizing the utilization of the GPU. You're not really making optimal use of the GPU if you have it work on very small graph structures. I taught users an interesting technique to batch your graphs to improve the parallelization achieved on a GPU. Here, you set up the adjacency matrices for multiple graphs by stacking them in a diagonal fashion, thus creating a giant graph that holds multiple isolated subgraphs. We discussed this as a part of the conceptual overview before we moved on to this graph classification implementation. Now, the data loader class into PyTorch Geometric automatically performs graph batching. I've instantiated the train loader, validation loader, and the test loader here. The training data has shuffle set to true, and I've used a batch size of 64 for all three loaders. I then run a simple for loop to iterate over the batches of data in the train loader, and I print out the number of graphs in each batch. Because we've specified a batch size of 64, you can see that the number of graphs in each batch is set to 64. Let's look at the first data batch's X features. Across 64 graphs in this first batch, we have 714 nodes, and each node, of course, has 3 features, and there are a total of 9,978 edges. If you look at step 2, the second batch, the number of graphs in the batch is again 64, but the number of nodes in this batch is 2,646, and the number of edges connecting these nodes is 9,714. Remember that in every batch, we have 64 isolated subgraphs, and each graph has a different number of nodes and a different number of connections.